All right, we have our Earth Science Reference Table, Solar System Data Table. So this is found on page 15 of your Earth Science Reference Table. So everyone should have Earth Science Reference Tables. And there you have page 15. We had the characteristics of stars, and we have a solar system data table. So what we're doing here is we're just going to answer questions about the solar system data table. So you should read all this so you understand the chart about the different columns, specific data that's in it, all types of information about moon phases that can be discovered in this. Venus being the hottest planet due to dense carbon dioxide producing runaway greenhouse effect. All right, so all this information that's given to you is because you're going to get questions on it. So all the answers to all these questions are in here. These are all things that are important for you to learn when answering the Regents questions, New York State Regents questions. So let's go ahead with this first one. Which planet is approximately 20 times farther from the sun than Earth is? All right, so let's go up here and let's take a look. Here is the Earth. And Earth is 149.6 million kilometers. So we want 20 times. We're going to do 149.6 times 20 equals 2,000. All right. So we have. It looks like Uranus is 20 times farther away than the Earth is. All right. So that seems simple enough. So now we come down here to our multiple choice. And we looked for Uranus. So the answer is Uranus, number 3. Which planet would float if it could be placed in water? Well, we know this from our notes already. But if you didn't know it, you would come over here and check the density. And we want something that's less than 1, right? There's only one planet that has a density less than 1, and that's Saturn. So the correct answer to that one is that Saturn would float if it could be placed in water. Which scale diagram best compares the size of Earth and the size of Venus? All right, so Venus is just slightly smaller than the Earth. All right, so this one isn't right because that'd be Venus is bigger. This is more like Mars, and then this is more like the Moon. So this would be a good representation of how Venus is. And once again, you could look at your data table. We have the equatorial distance, and you can see that Venus is 12,100 and Earth is 12,700. So you can see that Venus is just slightly smaller than the Earth. You could also see that Mars is half the size of the Earth, approximately half the size. And the Mercury is just a little bit smaller than Mars, but the Moon is a quarter the size of approximately quarter size of the Earth. All right, so let's go back. Oop. So 4 was the correct answer here. Which planet's orbit around the sun is most nearly circular? Well, we had this in our notes also. And what we have here is we have our eccentricity of the orbits, all right, to see which one is mostly circular. And Venus would be the correct answer for that. Mercury is the most elliptical. So out of these answers, Venus is the correct answer, being most nearly circular. Terrestrial planets have move more rapidly in their orbits than the Jovian planets because terrestrial planets are closer to the sun. All right, so our answer is closer to the sun. The closer you are to the sun, the faster you revolve around the sun. How do Jupiter's density and period of rotation compare to Earth's? All right, so we're looking for density and period of rotation. So we have up here density. So we have Earth is 5, Jupiter is 1, so it's less dense. And then we have period of rotation, 24 hours in a day for the Earth to rotate. Only 9 hours, only like 10 hours. So Jupiter has a shorter period of rotation and is less dense. So let's go back here. So Jupiter is less dense and has a shorter period. So number 6 is 2. Which graph represents the relationship between the planet's average distance from the sun and the time the planet takes to revolve around the sun? So this is on here. We have distance. So Mercury is closest, and then we have period of revolution around. So it takes 88 days. But then when you get down here, obviously Earth is 360 days. It gets larger and larger and larger. And then you have 164.8 years for Neptune. Everything just keeps getting larger and larger. So we look at the graphs that were given to us, and only one shows as the average distance from the sun increases, the period of revolution increases. All of these do not. Everything stays the same as the distance. This one is it decreases, the period of revolution decreases. So we know it increases. So 2 is the correct answer. And this is an exponential increase. That's what the curve means. Which planet takes more time to complete one rotation on its axis than to complete one revolution around the sun? So it takes more time to complete a rotation, like in a day, than it takes to go around the sun. And we can come up here and we have, all right, it takes 59 days for Mercury to revolve, 88 days to get around the sun. So this one's not true. But if you look at Venus, wait, what do we got here? Let's see what that question is again. Which planet takes more time to complete one rotation on its axis than to complete one revolution around the sun? All right, so it takes more time to do one rotation. So this one is 243 days for Venus, and it only takes 225 days to go around the sun. So this one, Venus, is the correct answer. It takes longer for a day to take place, or one rotation, than it does to get around the entire sun. So Venus was the correct answer for this one. Venus, too. The sun's position in space is best described as approximate center of. It's the center of our solar system. That's why it's called a solar system. It's a system that revolves around a star, and our star is the sun. So 4 is the correct answer. Which of the following planets has the lowest average density? All right, so these are just the terrestrial planets, and if we go up to our terrestrial planets and look at the density of just the first Mercury, Venus, Earth, Mars, we have Mars has 3.9, right? So this is 5, 5, 5, and Mars is 3.9. So Mars has the lowest. Mars has the lowest average density. Which statement correctly compares the size, composition, density of Neptune to Earth? Right? Neptune is larger. Right? We can look up there. It's a gas giant, and it's less dense than Earth. So 11, the answer is 2. You can check the charts for that. Compared to Mars, Mercury moves more rapidly in its orbit because Mercury is closer to the sun. So you're going to hear that one a lot. The closer you are to the sun, the faster you move around the sun. The farther away you are, the slower you move. Which planet is approximately 30 times farther from the sun than Earth is? All right, so what we have to do is we have to take our calculator. We have to find out distance of Earth from the sun. All right, that was our first question. 20 times was Uranus. So 30 times, oh, well, there's only one planet left anyways. But if you take the calculator and do the math, you do 149.6 times 30 equals, we have our answer, and it's close to Neptune. So Neptune would be the correct answer for that one. Boop, boop, boop. 30 times farther from the sun than Earth. Neptune, 4. Which celestial feature is largest in the actual size? All right, the moon, Jupiter, the sun, the galaxy. Well, the moon is smaller than Jupiter, and Jupiter is smaller than the sun, and the sun is just one of millions of stars in the galaxy. So the galaxy is the largest actual size. Which planet, known as a gas giant, the planets known as gas giants include Jupiter, Uranus, and so Venus, Mars, and Earth are all terrestrial planets. Saturn, Neptune, and Uranus, and Jupiter are all gas giants. So Saturn is the correct answer. The diagram below represents two planets in our solar system drawn to scale, Jupiter and Planet A. Planet A would be, let's see, what is only a little bit smaller than Jupiter? We come up here, and we have the density of Jupiter, and you could see that Saturn is just a little bit smaller than Jupiter. Uranus is like a third the size of Jupiter, and so is Neptune. And then these things are little tiny things. So Saturn would be that planet A, if that's to scale. So 3, Saturn. The same side of moon always faces Earth because the moon's period of rotation rotates once as it completes once. So we go up here and we look at the rotation and the revolution around the planet. So Earth's moon takes 27.3 days to go around Earth, and it rotates on its axis 27.3 days. So the period of rotation and the period of revolution are equal to each other. So we come down here and we say, it says the moon's period is longer than, no. The moon's period of rotation is shorter, no. The moon rotates once as it completes one. So 1 and 1 are equal to each other. So 3 is the correct answer. Question 18 only has 3 choices. Well, that's smart. Compared to the average density of the terrestrial planets, Mercury, Venus, Earth, and Mars, the average density of the Jovian planets, the gas giants, the average density is less. Compared to the average density of the terrestrial planets, compared to the average density of the Jovian planets is less. So your correct answer for 18 is 1, less. The average density of the Jovian planets is less than the terrestrial planets. Which graph best represents the relative periods of rotation of Mercury, Venus, Earth, and Mars? So we have all these bar graphs of the period rotation, and we're looking for one that shows a bar graph of these planets. So we go up here to our table and we look for period of rotation. Mercury is 59 days. That's big because we're only 24 hours. And Mars is basically 24 and a half. So Earth and Mars are very close to each other. Mars is just a little bit larger. But Venus is 243 days to turn once. Earth days, that is. For one Venus day is 243 Earth days. So Venus is huge. Mercury is very big. And then these are just 24 hours, like one Earth day for both of those. So let's go back and look at this. 19. And we'll see. This is like one Earth day. Those are pretty much similar. And Venus is huge. So 1 is the correct answer for 19. All right, now we have base your answer to question 20 on the accompanying data table, which provides information about 4 of Jupiter's moons. Identify the planet in our solar system that is closest in diameter to Callisto. So diameter of Callisto is 4,800. So now we got to find a planet that has something close to 4,800. Oh, that's Mercury. So there you go. So Mercury is what you write here. Mercury, the planet. In 1610, Galileo was the first person to observe, with the aid of a telescope, these 4 moons orbiting Jupiter. Explain why Galileo's observations of this motion did not support the geocentric model of our solar system. Well, the geocentric or Earth-centric model, geo for Earth, means that everything revolves around the Earth. If these 4 moons revolved around Jupiter, then obviously everything doesn't revolve around the Earth. So the answer would be, because the moons revolved around Jupiter and not the Earth, it did not support the geocentric model of our solar system. That's easy. Let's see, 22. Planet D's diameter is 10 times greater than Earth's diameter. So here's planet D, and there's little Earth, which is weird. What planet in our solar system has a diameter closest in size to the planet D? All right, so now we have to go to our chart. We have to take Earth's diameter times 10 to find a planet that is comparable. Boop, boop. All right, so get our little calculator out, and we have Earth's diameter, 12,756. 756 times 10 equals, let's see, we're looking for something that's 127. Oh, right here, 120,000 Saturn. So our answer, boop, boop, boop. What we would write here, what planet in our solar system has a diameter closest in size to the diameter of planet D? Saturn. Why does planet B revolve faster than planet C? Well, here's planet B next to Epsilon, and here's planet C. Planet B is closer to the star than planet C. So we would write that. We'd write planet B is closer to the star than planet C. And that means it revolves faster. Base your answer to question 22, accompanying diagram. This diagram shows a pose of the solar system. All right, so here's the terrestrial planets. Here's our gas giants. Neptune's not on here. And here's the asteroid belt. What is the average distance in millions of kilometers from the sun to the asteroid belt in millions of kilometers? Well, the asteroid belt is about scattered, just gumballing it here, halfway between Mars and Jupiter. So we can go up to our charts and look what the distance is halfway between Mars and Jupiter. So what we do here is we have our little calculator, and we say, okay, Mars 227.9 plus Jupiter 778.4 equals, divided by 2, equals 503.15 million kilometers. So our answer here would be approximately 500 million kilometers, and that would be your answer between, and that falls between Mars and Jupiter. We could check our work up here, and we're like, oh, let's see, Mars was 227, and we could say about 200. We could say this is about 800, and halfway between 200 and 800 is 500. And that we could do it that way too if we just took a gumball estimate. It's a big distance, so it's really, you don't have to be spot on. All right, so let's look here. All right, base your answers to question 23 on accompanying data table, which shows the average distance from the sun, average surface temperature, and the average orbital velocity of each planet in our solar system. On the graph below, draw a line to indicate the general relationship between the planet's average distance, which is this chart, from the sun, and its average orbital velocity, which is this column here. All right, so average orbital velocity, average distance. All right, so let's go over here and get our draw tools, and I'm going to pick, let's do green, and there's other shapes we can do, but all right, so 58 is close here, and 47, let's look at all these numbers, is pretty high. So we're going to say this is 10, 20, 30, 40, 50. Okay? And then what do we got here? 58 to 4,000. Well, this is a really big number, so things are going to be wacky. So we'll just do this. We can put a scale here, but it really is kind of wacky. So we'll just say, let's pick a new color, blue. We'll say this is 50, so this is 47.9, and that's close to here. And then we have 35, so this was 10, 20, 30. 35 is about here. And then we have 29, which is about, this is a distance a little bit farther, about here. And then we have 24, so this is 10, 20. This is about there. And then we have 13, so this is 10, 13. This is getting farther out, pretty far. And then we have 9. This is 10. So we got something about there. And then we got 8. Is about there. And then we got 5 is about there. And then we're going to take this color and we're going to go wee. And that's what we get. So that's what your graph should look like. What causes Venus to have a higher average surface temperature compared to Mercury, which is closer to the sun, and Venus? Well, this was in our notes, and it was also on this page. If you go all the way up here, it says, blah, blah, blah. Venus is the hottest planet due to dense carbon dioxide producing runaway greenhouse effect. So that's your answer right there. So you put over here, the greenhouse effect causes Venus to have a higher temperature than Mercury. Mercury doesn't have a lot of gases. And that's it. So go ahead and make corrections to anything you didn't do right, and then you can be done with it.